Hi children, this is Lakshmi Arvinda. Today we are going to see the chapter number 2, rational numbers. See, this is the chapter number 2, rational numbers in your new textbook, children. Now, before going into the chapter, first we will see the introduction. Natural numbers, which will be denoted by using a capital N. These are also called as a counting numbers, and which will be including 1, 2, 3, 4, 5 and so on, means which will start from the 1, there will be no end. And whole numbers, if we'll add 0 with the natural numbers, then we will get the whole numbers, which will be like 0, 1, 2, 3, 4, 5 and so on. Next one is integers, which will be denoted by using capital I or capital Z. So if we'll add negative numbers to the whole numbers, we will get the integers. Next one is rational numbers. Rational number is a number which will be in the form of P by Q, where P is the numerator, Q is the denominator, and P and Q may be any of the integer. Any of the integer means it may be a negative number, may be a positive. And Q should not be equals to 0. P may be a 0, but Q should not be equals to 0. Now we can see one small chart which will show the natural, whole, integers and rational numbers. If we'll see here, natural numbers will be under whole numbers will be under integers will be under rational numbers. See, here you will get a doubt that natural numbers is there in a whole numbers, okay, whole numbers is there in a integers, okay, but how these three are in a rational numbers? Because as I told you, rational numbers should be in a form of P by Q. How it is means, if you will take any integer or whole number, for example, I'll take 4. So 4, it is not in a form of P by Q. How it is a rational number? Means I can take 1 as a denominator without changing any value. Yes. So now 4 will become 4 by 1. So where it is showing in a form of P by Q. So we can consider it as a rational number. Next, arithmetic operations on the rational numbers. Here we are going to see basic arithmetic operations. What are those 4, children? One is addition, subtraction, multiplication and division. So now we are going to see that 4 operations, how to perform on the rational numbers. First one is addition of rational numbers with the same denominator. If we are going to add the 2 rational numbers, both are having the same denominator, it's very easy, children. Just add the numerators. That's it. We should not add the denominators. Whenever we are adding or subtracting the rational numbers, we are not going to add or subtract the denominator. We will just make the denominator common, or already if it is a common, then we will write the same denominator for the result also. And we will add the numerators. Here example 2 by 9 plus 3 by 9. If we will see, add the denominator, add the numerators 2 plus 3, that is 5, and denominator will be same, 9. That's it. Next, if we are having the rational numbers which is having a different denominators, then how to add that rational numbers? Means first we have to convert the denominators into same by taking the LCM. After taking the LCM, we will multiply with that LCM to the rational number, and also we will divide with that rational number. Then we will get the same denominator. After getting the same denominator, as you know already how to do the addition. So here I will clarify that with the example. We are going to add 7 by 6 and 2 by 9. So how to, if we will observe here, 1 is having a 6 as a denominator, one rational number is having 9 as a denominator. So we are having a different denominators, we cannot proceed directly by adding the numerator. So first we have to convert the denominator as a same by taking the LCM. So take the LCM of 6 and 9, we will get 18. Now multiply 18 by both the rational numbers. If we will multiply, it will get balanced, children? No, children. Whenever we are multiplying, we have to divide also with the same number. So if we will multiply and divide 7 by 6 into 18 and 2 by 9 into 18, we will get, here we can see in detail way, 7 by 6 into 18 is equals to 6 1s are 6 3s are. Then 7 3s are 21 by 18 divided by 18. Next 2 by 9 into 18 we will get here 9 1s are 9 2s are 2 2s are 4 by 18. Now we are having the two rational numbers 21 by 18, 4 by 18. We can add the numerators because we are having same denominator after adding 25 by 18. Okay, next children, subtraction. Subtraction is little bit easier, same as addition, but what we have to do means first we have to change the sign of the subtrahend, means which we are going to subtract rational number. Then we will follow the same procedure as it is as the addition, means which we are going to change the subtrahend, that is the rational number which we are going to subtract. No, that changing the sign is called as a additive inverse. Okay, means the first rational number from which number we are going to subtract, that rational number will be same, and the second rational number, the rational number which we are going to subtract, that rational number we will change the sign. If it is a plus, we will take the minus. If it is a minus, we will take the plus, which is called as additive inverse of that number. Then we will follow the same procedure as in addition. Next, multiplication of rational numbers is much easier, children. Nothing. We no need to check whether it's a denominators are same or different, anything. Just see, just multiply numerator 1 into numerator 2, means just multiply the numerators and multiply the denominators, and multiply the numerators, write in a numerator place, multiply the denominators and write in a denominator place. If it is there any cancellation, we have to do that cancellation, we have to reduce the form and we have to write. Next one, children, here we can see the example, multiply 3 by 8 and minus 9 by 11. So if you'll see the solution, 3 by 8 into minus 9 by 11, we will multiply 3 into minus 9 by 8 into 11, minus of plus minus 3, 9 3s are 27 by 88. Next, division. Division of a rational numbers is just a reverse process of multiplication. What we have to do means, first number, that is dividend rational numbers, we will write like that only, and we will change the division sign into multiplication. After that, the second rational number, that is divisor, that divisor we will take the multiplicative inverse. Multiplicative inverse or reciprocal means changing the numerator into denominator, denominator into numerator. See, I will clarify that with the example. 11 by 12 divided by 7 by 4. Now, the first rational number, that is dividend rational number, 11 by 12, we will write like that only. Now, division sign, we are going to change into multiplication. Then it will be correct if we change the sign? No. For that action, for that changing, we are going to change the next fraction, next rational number. We are taking a reciprocal or multiplicative inverse. What is that means? 7 by 4 will become 4 by 7. Now we can cancel here. What is that means? 4 1s are 4 3s are 4 in a numerator, 12 in a denominator. Cross cancellation I am doing. 4 1s are 4 3s are. Now what is there in a numerator means only 11 like that only. In a denominator 7 into 3 21. Next, properties of rational numbers. We already seen this properties, general properties for the whole numbers, integers in a last classes, children, in a 7th and 6th class. Now, the same properties only we are going to see for the rational numbers. Okay, here if we'll see what is meant by rational number, as we know already, it will be in a form of P by Q, where P and Q are two integers and Q should not equals to 0. And it will be denoted by capital Q. Now, closure property. What is the closure property means? First, I will just discuss about the closure property. Then I will explain with all. Here, whenever we will do some operations between, some operation in the sense, any arithmetic operation between two rational numbers, then we have to get a rational number as a result. Then this is called as a closure property. So, here if we'll see, both these rational numbers are closed under addition, subtraction and multiplication. For example, if we'll see here, 7 by 6 plus 2 by 5. Then if we'll multiply, if we'll add, we will get 47 by 30, which is a rational number again. If we'll add two rational numbers, we have to get the rational number. So addition is satisfying the closure property. If we'll take subtraction also, children, any two rational numbers, if you'll subtract, you will get another rational number. Here with a small example, 5 by 6 minus 1 by 3. If we'll do step by step, then we will get 1 by 2, which is a rational number. Next one, 2 by 5 into 3 by 7. So again here if we'll do the multiplication, then we will get 6 by 35, which is a rational number. So what we can conclude, both the addition, subtraction and multiplication are satisfying the closure property. If we'll perform, then we will get a rational number again. If we'll come for the division, it is not under closure property. Why? Because the division is not under closure property, because division by 0 not defined. Okay, so if whenever we will take the 0, division by 0, then it will not be defined. So why? Except 0, all the remaining again it will be under the closed, under division. Okay, next, commutative law. Commutative law is nothing but if we'll take any two rational numbers, if we'll perform any operation in any way, by changing the first number into second number into the first number, we have to get the same answer. Okay, so this will be satisfied by only addition and multiplication, not by subtraction and division. Why? Because if you change the first number to second number to first number, you will not get the same answer in subtraction and division. Even if you want, you check once, children. See, if we will take addition and multiplication, whatever the way you will multiply, whatever the way you will add two rational numbers, you will get the same answer. So which both will satisfy commutative means addition and multiplication of rational numbers will satisfy the commutative law, and subtraction and division will not satisfy the commutative law. Here example, simple example, 2 by 5 into 3 by 7. If we'll change the order, first I will take 3 by 7, then I will take 2 by 5. Whatever the way we will multiply, we will get 6 by 35. Next, associative law. This is just like a commutative. In a commutative, we will take two numbers. Here we will take three numbers. That's it. Here, whenever we will take three numbers, children, if we will change the order, okay, means first we will add first two numbers, then we will add to third rational number, or else first we will add next two rational numbers, then we will add to first rational number. Whatever the way we will take, we will get the same. Then we will call it as a associative law. And what and all operations will satisfy this associative means same like a commutative, both addition and multiplication will satisfy the associative law, but not division and subtraction. Division and subtraction will not satisfy the associative property. If we'll change the order of the numbers, means dividend to divisor, divisor to dividend, then there will be no same result at all. Okay, subtrahend to menuend to subtrahend, like that if you will change in a subtraction also, you will not get the same answer at all. Okay, next, distributive property, which is one of the important property for wherever you will go, some mathematical operations and all, maximum will depend upon this distributive property. So what is meant by distributive property means, if we are having three rational numbers, a by b, c by d and e by f, then if we are having in a form of a by b into c by d plus e by f, then we can write it as a by b into c by d plus a by b into e by f. Means we are just distributing. Now here it is like one set, a by b into one full term. It is, now we are going to write, it is distributing. Here it is like, you can remember that monomial with the binomial multiplication. If you remember in our last videos, I explained you monomial with the binomial multiplication, how we did. Like that, we are going to distribute a by b into c by d plus a by b into e by f. Here I'll explain with the example 1 by 3 into 2 by 5 plus 1 by 5. So how we can write 1 by 3 into 3 by 5. First I am just doing this side. So 2 by 5 plus 1 by 5 will get 3 by 5. So 1 by 3 into 3 by 5 will get 1 by 5 as a result. Okay, next children, come for 1 by 3 means left hands. I did now right left hands. So now I am going to do the right hand side. 1 by 3 into 2 by 5 plus 1 by 3 into 1 by 5. If we will multiply 1 by 3 into 2 by 5 will get 2 by 15 and 1 by 15. If all together if we'll add 2 plus 1 in a numerator will get 3 by 15. That is nothing but 1 by 5. So if we'll observe both the sides, both the things, we will get 1 by 5 in a left hand side also, 1 by 5 in a right hand side also. So we are getting 1 by 3 into 2 by 5 plus 1 by 5 is equals to 1 by 3 into 2 by 5 plus 1 by 3 into 1 by 5. Therefore, multiplicative distribute, this is called as a multiplication over the addition. Means distributive property of multiplication over the addition is satisfied. Now we will see the same property, distributive property of multiplication over the subtraction. How it will be means in an addition place we will get subtraction. That's it. The remaining all will be same. Here a by, if three rational numbers a by b, c by d and e by f are there, then if a by b into c by d plus e by f, then just like a splitting means distributing a by b into c by d, minus is there, so we will get minus, and a by b into e by f. Here we are having the same example for the minus. We will see 1 by 3 into 2 by 5 minus 1 by 5. So here we will get, first if we will multiply inside the brackets we will get children 2 by 5 minus 1 by 5 will get 1 by 5. So 1 by 3 into 1 by 5, multiplying numerators 1 into 1, 1, 3 into 5, 15 over. Now come for here. 1 by 3 into 2 by 5 minus 1 by 3 into 1 by 5 means right hand side, the distributive thing I am doing. Now first term is 2 by 15 minus 1 by 15. That is 2 minus 1, 1 by 15. Now we can observe that both right hand side also we got 1 by 15, left hand side also we got 1 by 15. So it is satisfying. Now this is called as a distributive property of multiplication on subtraction over subtraction. Now some more properties to be remembered children. As I told you is identity property. This identity, what is meant by identity means, for example, if you do any operation with some number, then you have to get the same number as a result. Okay, here we are having for only addition and multiplication is having a identity property. Again, subtraction and division is not having. Okay, how it is means, for example, I am taking one rational numbers 4 by 5. If you will add 0, 4 by 5 plus 0, then you will get 4 by 5 as a result. Okay, so here you are getting the same number as a result 4 by 5. That is called as an identity. And here we are using the addition. So identity of addition. What is the identity? Which is called as a additive identity, means 0 is called as a additive identity, because by adding 0 only we are getting the same number. Okay, so for rational number 0 is called as a additive identity. If we'll take for the multiplication, with what number if we'll multiply we'll get the same number as a result, that is 1. So 1 is called as a multiplicative identity, that is 4 by 5 into 1 is equal to 4 by 5. Now for rational number x by y, if we'll take any rational number, one more property is there, inverse property. This is also there for only two. One is addition and second one is multiplication. Either additive inverse or multiplicative inverse. Whenever we'll take, already I explained previously what is meant by additive inverse means, whenever we'll change the sign, there will be no change in a rational number, only change in the sign. then we will call it as a additive inverse. If it is there plus, we'll change it to minus. Minus is there plus. Here if we'll see minus, if we'll take one rational number x by y, then minus x by y is called as a additive inverse. For example, minus 1 by 2 is there, then it's additive inverse of 1 by 2. Next, if we'll take x by y, for that multiplicative inverse if we'll take, then multiplicative inverse will be y by x. Numerator will go for the denominator, denominator will come for the numerator place. Here 5 by 4 is called as a multiplicative inverse for 4 by 5. This multiplicative inverse is also called as a reciprocal. Next, children, will see the example exercise sums. First main is about evaluate using the properties. So first question if we'll see, minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. So here if we'll see what property first I am going to use means, here if we'll see this 3 by 5 in this set and here in this set 3 by 5, both also same number we are having, same rational number we are having. So what I am going to do means, I am going to rearrange this term and this term. So if you are going to arrange using two terms, whatever the way we will get the same answer, that is commutative. If you will apply for the three numbers, that is associative. Now after rearranging, here minus 2 by 3 into 3 by 5 minus 3 by 5 into 1 by 6, I will bring this side, and 5 by 2 I will send that side. Now if I will see in the middle, 3 by 5 is there common in both the terms. So I will take out the 3 by 5, then I will write the remaining. From this, if 3 by 5 will go out, what is the remaining? Minus 2 by 3, and minus from here 3 by 5 if it will go outside, the 1 by 6 is remaining, plus 5 by 2. Now here if we'll see what is this property, children, here it is in a distributive way. Now I am writing, it's like a short form. This is distributive property. What is this property? Distributive property. Then after I am going through the 5 by 2, it is the same as it is. Now I am going to perform whatever it is there inside the brackets. Now if we'll see inside the bracket, minus 2 by 3 minus 1 by 6. So here if we'll observe, both the denominators are different. So first we have to equalize the denominators. No need to take the LCM and all, children, because small numbers. So to get the 6, if we'll multiply 3 with 2 is enough. So I am multiplying minus 2 by 3 into 2 by 2. By that way we will get 3 by 5 as it is, and to minus 2 by 3 into 2 by 2 we will get minus 4 by 6 minus 1 by 6 plus 5 by 2. Now if we'll see here, plus 3 by 5 as it is, if we'll add the inside, minus 4 minus 1 numerators, because the denominators are equal, we can add the numerators, minus 4 minus 1 minus 5 by 6 plus 5 by 2. Now if we'll see here, 5 and 5 we can cancel, and 3 ones are 3 twos are. So the remaining is minus 1 by 2. This way of cancellation is called cross cancellation, plus 5 by 2. Now here we are having both the denominators are same, so we can add the numerators. By adding the numerators, minus 1 plus 5 we will get plus 4. So plus 4 by 2 we will get 2 ones are 2 twos are, answer is 2. First main. Next question is, write the additive inverse of each of the following. Additive inverse is nothing but just changing the sign. If it is there plus, we have to change into minus. If it is there minus, we have to change into plus. So here plus 2 by 8 it is there. So after changing the sign, it will become minus 2 by 8. Then here it is minus 5 by 9 it is there. After changing the sign, minus it will become plus, and 5 by 9 as it is. Next, what is our next question means, verify that minus of minus x is equals to x for x is equals to 11 by 15. So for if we'll substitute x is equal to 11 by 15, if we'll apply minus of minus, then we should get x. So apply minus of minus 11 by 15. Now if we'll take 11 by 15 minus of minus we will get again plus 11 by 15 is nothing but plus 11 by 15 again the value is x. So we are getting minus of minus x only, no? That's it. Now find the multiplicative inverse of the following. Multiplicative inverse means there will be no change in the sign. Only the change in numerator and denominator. Numerator will become denominator, denominator will become numerator. Here, first question 13. So, nothing is there in the denominator, so I will take 1. So, multiplicative inverse means minus I will write like that only, and 13 by 1 will become 1 by 13. Next, minus 13 by 19. So multiplicative inverse, there will be no change in the sign, minus like that only, and 13 by 19 will become 19 by 30. Next, multiplicative inverse of this entire set they are asking. So what we have to do means, first we have to simplify this set. Whatever the product, first we have to simplify, then only we have to write the multiplicative inverse. So for simplification, multiplication, first we have to multiply both the numerators, then denominators. So if we multiply the numerators, minus 5 into minus 3 by 8 into 7. So minus of minus plus 5 3s are 15 by 8 7s are 56. So the multiplicative inverse is 56 by 15. Next children, name the property under multiplication used in each of the following. Now we have to name the property whatever they used here. Here first question, minus 4 by 5 into 1 is equals to 1 into minus 4 by 5 is equals to minus 4 by 5. So what you can see here children, here if we'll take only except this answer, if we'll take this 2 only, we can say that whatever the way we will multiply, we will get the same answer, 2 rational numbers, that is commutative. But if we'll see the answer, we are getting minus 4 by 5. So the number, one number if we'll multiply with 1, the rational number, you are getting the same number, is nothing but identity. So the entire is multiplicative identity. Next here if we'll see two numbers, the minus 13 by 17 into minus 2 by 7 is equal to minus 2 by 7 into minus 13 by 7. So two numbers, whatever the way we will multiply, we will get the same result. Two rational numbers, whatever the way we will multiply, we will get the same result. So what is this property? Commutative property over multiplication. Next question is write the. Here our next question, multiply 6 by 13 by the reciprocal of minus 7 by 16. So first we will find. Here our next question, multiply 6 by 13 by the reciprocal of minus 7 by 16. So first we will find out what is the reciprocal of minus 7 by 16. So reciprocal of minus 7 by 16 is minus will be same, then numerator will become denominator, denominator will become numerator, that is 16 by 7. So now we have to find the product of these two numbers. So 6 by 13 into minus 16 by 7. If we will multiply numerator into numerator by denominator into denominator, plus of minus minus 6 into 16, 96, 13 into 7, 91. Next, tell what property allows you to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. Just children, here first we will multiply this, then we will multiply the result with this. Here first we will multiply this 2 and the result will be multiplied with the third number. So what is this property children? It is associative property. Okay, dealing with the three numbers with the same sign. Then it's a associative property. Next, associative property over multiplication. Next, is 0.3 the multiplicative inverse of 3 1 by 3? Why? If it is yes, why? Or why not? Here, first we will, why or why not they asked. So first I will start from the reasoning only. So given number is 3 1 by 3. So we can write, it is a mixed fraction. Improper fraction is 3 3s are 9, 9 plus 1, 10 by 3. So multiplicative inverse is 10 by 3. We can write 3 by 10. So 3 by 10 is nothing but 0.3. So Yes, 0.3 is the multiplicative inverse of 3 1 by 3. Yes, 0.3 is the multiplicative inverse of 3 1 by 3. The reason also is there up. Here is your practice time, children. Please do it and send me back the answers within a week. And this is a project. Please do write it in a project book which you are having 100 pages white book. Thank you, children. Please keep learning. Lakshmi.